Hi everyone, in today's lesson I'm going to go over the first 4 or 5 questions from our integration test. So at this time it may be helpful to take out a piece of paper, pause the video, and copy down the first few problems, and then hit resume when you're ready. Okay, so first, to recall integration, we have to add one number to the exponent and then divide by that number. So in this first problem, we are going to take the antiderivative of x squared by just adding 1 to the exponent, which would make it 3, and divide by that number. Same thing for the second part. We have negative 3x. The power was originally a 1, so we're going to change it to a 2 by adding 1 and dividing by that power. And then for the constant 10, we're just going to add an x. And I want to take this antiderivative from negative 2 to 1. So technically you can plug this into your calculator using the Math 9 function, or we could try to do it by hand. And that would require us to do the top minus the bottom. So over here, I'm going to plug in 1 for x. So 1 to the third over 3. Minus 3, 1 squared over 2, plus 10 times 1. So now we're going to get this answer, and we'll put it over here. And then we're going to do the same thing, except now we're going to plug in negative 2 everywhere I see an x. So negative 2 cubed over 3, minus 3, negative 2 squared over 2, plus 10 times negative 2. So we'll get that answer and put it here, and then we're going to subtract them. Okay, after typing it into my calculator, the first answer was 53 over 6. And after typing in the second part in my calculator, I got negative 86 over 3. So if we do the top, 53 over 6 minus the bottom, so minus a negative 86 over 3, our final answer should be approximately 37.5 for rounded numbers, or the decimal equivalent would be fine. All right, so that was problem number 1. All right, let's move on to problem number 2. Before I can do problem number 2, I want to actually double distribute this information that's right here. So I want to do, if you do a box method or double distribute, we want to multiply out 2x squared plus 7 times 2x squared plus 7. So if I double distribute, the first times the first is 4x to the fourth. The outers multiply to 14x squared. The inners multiply to another 14x squared. And the outers multiply to 49. And if I combine like terms, I have 4x to the fourth plus 28x squared. All I did here was add those two together, plus 49. So now this is what I want to take the integration of dx, right? That's the concept. So now the same thing that we did for number 1 is add 1 to the power and then divide by that number. So you should have gotten 4x to the fifth divided by 5 plus 28x to the third over 3 plus 49x. And then last but not least, we need that constant, because there is no definite numbers here or here like in the first problem. Okay, let's move on to problem number 3. Okay, number 3 was a little bit tricky. It requires us to rewrite this radical x as the same thing as saying x to the 1/2. So we're going to rewrite the numerator as 5x plus 1. This is going to stay. And the bottom is going to be written as x to the 1/2. Okay, now before we can integrate, we actually have to simplify. So what we know is that we can simplify using the Hart method. We can divide these two terms and then divide these two terms. So when I'm dividing 5x and x to the 1/2, remember we keep the base, the x's, and we subtract the exponents. And then we divide coefficients. So the 5 and the 1 are coefficients. So if we divide those, we get 5. If we have x and x to the 1/2, technically the x has a power of 1, and we're going to subtract 1/2. So obviously 1 minus 1/2 is just 1/2. So this is 5x to the 1/2 plus, now we're going to divide 1 and x to the 1/2. We technically can bring this up, or if it helps you, you can write this as 1x to the 0 power. But regardless, this simplifies to x to the negative 1/2. So now, like before, we're going to integrate this over dx. So add 1 to the power and divide by that power. But the rule that I showed you is that instead of dividing by a fraction, we're just going to multiply by its reciprocal. So we're going to keep the 5, that's here, leave a space, x. So when I take this 1/2 and add 1, it's the same thing as adding 2/2, right? So 2/2 is the same thing as saying 1, so plus 2/2 makes that 3/2. So this exponent is 3/2, and then we're going to divide by 3/2 or multiply by the reciprocal, which is 2/3. So then that gives me my final answer as 10/3 x to the 3/2. So now this is the same thing for this second term. We're going to add 1. So I'm going to add 2/2 to this power, which gives me 1/2. And then instead of dividing by 1/2, I'm going to multiply by that reciprocal, which is 2. And don't forget the plus sign. So then my final answer for this second term is plus 2x to the 1/2. And then don't forget the plus c for your final answer. And that's it. Okay, let's talk about number 4. So things to notice is that number 4 has definite integrals here and here, so we'll have to substitute. And we also have to understand the derivative. So you want to ask yourself, the derivative of what is secant squared? So you have your list of derivatives, so you could take a look at that. And you should know that the derivative of tangent is secant squared. So the antiderivative is just tangent. So we want to take tangent and evaluate it from 0 to pi over 3. So if we use the same mentality that we did in problem number 1, we need to take tangent of the top of pi over 3 and subtract it from the bottom, which is tangent of 0. So in order to find tangent of pi over 3, it probably would be helpful if you would convert pi over 3 to degrees. So to do that, we multiply pi over 3 times 180 over pi. The pi's cancel, and you're basically dividing 180 and 3. So I want to find tangent of 60, and then subtract that by tangent of 0. So to find tangent of 60, you actually have to use your exact value charts, which if you take a look, we've done those numerous times, take a look back in your notes, you'll see that it's radical 3. Now, tangent of 0 is a little bit harder. To find tangent of 0, you really need to know the unit circle. So I'm just going to draw a quick unit circle, and 0 degrees is right over here, and that's the point 1, 0. So you need to know that tangent is sine of theta over cosine of theta. And you need to know that sine is the y value and cos is the x value. So the y value is 0, right? That's the y value. The x value is 1. So when you do 0 divided by 1, you actually get 0. So tangent of 0 is 0. And then when you subtract these two things, the answer is radical 3. Okay, the last problem that I'm going to do is problem number 5. So the things that helped me answer this problem was on top of my paper, I wrote sine, cos, sine, negative cos. And remember, going forward are derivatives, so I'll put like f prime. right? Going forward. And going backwards is the integration. That's an integration symbol. So if I want to find the antiderivative of cosine, I'm here. I just have to go backwards to find the antiderivative. So the antiderivative of cosine is in fact sine. So all I have to do to find the antiderivative of 4 cos x, it's really just going to be 4 sine of x. And then to take the antiderivative of negative 3x squared, we follow the rules as before. So we're going to add 1 to the power and divide by that power. And again, we need to remember that we need a plus c here because there are no limits on the antiderivative here. So these can cancel in the middle. So my final answer is just 4 sine of x minus x cubed plus c. That is my final answer. All right, I think that's enough for today. So take a minute and write down these problems. If you'd like, you can get started on that assignment that's due on Sunday. All right, have a good one.